Good day, this is CSC 312 course. Today we'll be describing formal language and automata theory. Formal language and automata theory. Let me paste what I want to discuss on the screen so that you can follow along. Okay. Now, let me make it clearer. So we are describing formal language and automata theory. Formal languages and automata theory introduces you to the concepts associated with languages, computation, and machines. So let me paste another definition here to describe what I'm talking about. So we say formal language and automata theory introduces the concepts associated with what? With languages, computations, and machines. Formal languages are structured set of symbols governed by well-defined rules analogous to the grammar of natural languages. Formal languages are structured sets of symbols governed by what? By well-defined rules analogous to the grammar of natural languages. Now, it means that it is described in terms of set of symbols. What do we mean by set of symbols? And take note that these symbols are they are well-defined rules. They are symbols, but formal languages contain symbols that are well-defined rules, which you can compare or similar to the grammar of natural languages. So let me try to explain what I'm trying to talk about here. So the first thing we said was, the first definition is formal language and automata theory introduces the concept associated with languages and automata theory. Formal languages and automata theory introduces concept associated with what? With three things. We have languages, computation, and machines. So I further said let me try to adjust the resolution of my computer here. Seems it's not sharp enough so that you'll be able to see what I'm doing clearly. Okay. So you see, Formal languages are what? They are structured set of symbols governed by well-defined rules, which you can compare to the grammar of natural languages. When we talk of set of symbols here, we are referring to symbols generally. There are different types of symbols. You have numbers. These are symbols, numeric symbols. You have numeric symbols, right? You have letters like A, B, C, and what? D, and so on and so forth. So it could be capital letter, it could be small letter, right? So these are symbols. These are set of symbols. And when you refer to a single symbol, you only talk of a symbol. But when there are more than one, you talk of set of symbols. So we are talking about formal languages involve well-defined rules and contain symbols. So you have numeric symbols. I'm describing the symbols to you now. Symbols, we have different type of symbols. We have numeric symbols, right? We have numeric symbols. We have numeric symbol like this. So you have numeric symbols like this. You have letters. You have capital and small letters. You also have special characters. These are symbols like addition symbol, subtraction symbol, division symbol. There could be different type of symbols that you can imagine or you can talk about. So those are the things where formal language is made up. But it's not just symbols. They are structured symbols. They are structured symbols governed by well-defined rules, which means there is a rule governing these symbols that we are talking about, and is compared to natural languages. When you say natural languages, you mean language generally that people use to communicate with each other or with one another. You have English, Spanish, English language, Spanish language, and so on and so forth. So it is similar to the way humans communicate in natural language, in their language, natural language, and it's made up of set of symbols that are governed by well-defined rules. That is formal language. So it involves symbols, not just symbols, organized set of symbols that are well structured and well-defined rules. And we can compare it to language that we use to communicate with one another. We also have under this topic, as I said, the first definition I gave is, let me paste it so that you can see it. This is the first definition I gave. So we have formal language and automated to introduces us or introduces the concepts associated with what? With languages, computation, and machine. So I'm trying to use this to describe this first definition. All right? Okay. So let's look at the definition of automata theory. Automata theory is a branch of computer science. It explores abstract machines called automata, which can process and generate strings of symbols adhering to the described formal languages. Okay, so automata theory in short is used to describe formal languages. Formal languages are made up of symbols, not just ordinary symbols, well-defined symbols, and is analogous to what? To the grammar of natural languages that we speak. It's similar to it, but it's made up of a set of well-structured symbols. Now, automata theory is used to generate, process, and generate strings of symbols of the what? Of the formal languages. This is what we are saying here. So we have formal languages, which are strings of symbols. I've already explained that one, right? String of symbols, any form of symbols you can talk about, as I said, numeric symbol, alphabet, different characters. You have all these plus, negative sign, any form of sign you can imagine. You can create your own symbol as well. So you can invent your own symbol. So all these symbols are described, are generated. They can be processed. Okay, they can be processed and generated using what? Automata theory. Automata theory. So that is that about that. So in this course we are going to discussing advanced parts of this definition that we just talked about. So we'll be working with symbols, and we'll be seeing how those symbols could be processed and generated. And let me quickly mention that there is a word here, a word called strings. What are strings? Strings are made up of symbols. Okay, strings are made up of symbols. They are a set of symbols. For instance, if you write one, this is just a symbol. Okay, then when you have different set of symbols, it could be, you can add plus to it. This is a string. Although a single symbol can be referred to as strings, but when there are more than one, when you have a set of symbols, a set of symbols is referred to as strings. So automata theory is used to process and generate the strings of symbols of the former languages. All right. So another thing I want you to note here is this. We have we are still talking on the same aspect. So we are talking on formal language and automata theory. Let me increase the size of the font so that you can see it better. All right. All right. So another thing that we should note is that formal language and symmetrical theory provide a powerful framework. Okay, they provide a powerful framework for understanding and designing machines with application ranging from compiler design to natural language processing, with application ranging from what? From compiler design to natural language processing, robotic and control system, software testing, hardware design, verification and pattern recognition. This is the field that requires where some of the applications of formal language and automated theory. So it's a very important topic in computer science, and that is why we are studying it. So remember, we have mentioned machine in the other definition. We have mentioned what machine is in the other definition. We said that formal language are structure sets. We describe them as structure sets. Okay. We say they are structure set of symbol governed by well-defined rules, which we can compare to the grammar of natural languages. Now, automated theory is a branch of computer science that explores abstract machines called automata. So these machines are what can be processed. These abstract machines are called automata. They are they are what can process. These abstract machines are what is used to process and generate strings of symbols. Okay, let me use it again. Automated theory, a branch of computer science, explores abstract machines called automata, which can process and generate strings of symbols following using formal languages. Formal languages are made up of symbols, which are not just symbols, they are well defined and well structured. But automated theory explores abstract machine called automata. So which is used abstract machine to process and generate string of symbols using formal languages. So that's why we say here in the second definition we say that it provides the formal language and automated theory provide a powerful framework for understanding and designing this machine. So is this machine that can process and generate string of symbols, okay, provided by formal languages. It is this machine. So in formal language and automated theory provide a powerful framework for us to understand how we design this machine. That is, we manipulate and generate language. How do we design it? And the application ranges from compiler design to natural language processing, robotic and control system. It has so many applications. Okay, software testing, hardware design, and verification and pattern recognition. For instance, when you talk of natural language processing, NLP, we are talking about the way language can be translated, analyzed. For instance, you can convert text to speech. You can convert speech to text, and so on and so forth. Okay, so that is that about that. So don't forget, these are two definitions, but I gave you one definition before now. I want to go back to it because I want to use it to explain something here. Okay, so the first definition was, let me try to bring this thing so that we can see. So the first definition was is this: okay. So we said formal language on Twitter to introduce you to concepts associated with languages, computation, and machines. Okay. So the second definition, the other definition that we have, this thing is not working the way I want it to work. Trying to fix it. You know why it's doing like that. Okay. Let me reopen it. Or go to Microsoft Word directly. Okay. So this was the first definition I gave here. Okay. Concept words is made up of concepts associated with what? Languages, computations, and machines. Right? So you can see this definition contains natural languages. Okay? It is similar to natural languages and it can be applied to natural language processing, which was what I mentioned. I hope you can see the screen, which was what I mentioned here. Which is what I mentioned here. So formal language, I think, to introduce you to concepts associated with languages. So the concept associated with languages, computation. When we talk of computation, it means a system that accepts inputs, process, and generate output. So you have the definition in your handout. I just want you to have an in-depth knowledge of what it means. So it is with languages, computation, and machines. So these machines here are called what? Are called automata. They are called automata, and they can be used to generate and process strings of the what? Of the formal language. Okay? So that's why we have formal language and automata introduces you to concepts associated with what? Languages, computation, and machines. So the machines are called automata, which they are used to, which can process and generate strings of symbols. Okay, adhering to the formal languages. Now I want to talk a bit on computation. Computation, like natural languages, are expected to deal with information in its general form. Consequently, computation functions as manipulation of what? So you have the definition in your note as well. I'm just trying to explain it. These are the two definitions you have in your notes, so that you know what, when you read it, you know what they are trying to say there. The first one is this, I've explained it, and this is the second one. What happened? Okay, this is the second one. Don't know, the screen has changed a bit. This is the second one, and this one you can see computation like natural languages are expected to deal with information in its general form. When we talk of natural languages, we mean the way we used to communicate with one another. Like you can communicate in English, Yoruba, Spanish, or any other languages, French. So that's computation. So all these things are composed of symbols. That's what they are trying to say. Computations, the way we talk, the way we talk and process languages, our language contains what? They contains symbols. They are made up of symbols. The smaller units are symbols when we analyze them. Consequently, computation functions as manipulation of integer graphs, programs, and many other kind of entities. Consequently, computation functions as what? Manipulation of what? Integers, graph, and it's like this thing is not clear, right? Is it clear? It's clear. I'm seeing like double lines. Are there double lines there? Okay. I need to take some rest then. So let me explain this topic, then tomorrow we'll move further. So computation like natural languages are expected to deal with information in its general form. Consequently, computation functions as manipulation of strings of integer, graph, and program, and many other entities. However, in reality, computation only manipulates strings of symbols that represent objects. The subsequent discussion in this course will necessitate the following definitions that we have. So as we go further, we will see the things we are trying to explain and talk about. So I'll be stopping the class now. Subsequent lecture we'll be discussing alphabet string representations, formal theory, and some other things. Thank you.